Okay, here we go. We're doing the polynomial operations practice test number 1. And our first section is over combining expressions. So this problem number 1 can be done two ways. We could either bounce off this minus sign. We can say 2x squared minus 3x squared is a negative x squared. Negative x minus a 5x is a negative 11x. And 1 minus a negative 3, if we put that in our calculator, will be a positive 4. So looking at it that way, we're going to end up with the answer D. And the second way to do it is to not bounce off of the minus sign, but just set it up with the understanding that this minus sign goes to everybody in this parentheses that follows the minus sign. And what we can do is we can distribute a minus sign. And I know that sounds really weird, but the way I taught it in the other videos is to say instead of a minus sign, it then now becomes a plus sign, which means everything in the parentheses that follows, this change sign also have to have a change sign. So instead of being a positive 3x squared, that'd be a negative 3x squared. Instead of a positive, that's a negative 5x. Instead of a negative 3, that'd be a positive 3. Then you don't have to bounce off anything. You can just combine your like terms. You can say 2x squared minus 3x squared. Yep, that's negative x squared. Negative 6x minus 5x. Yep, that's negative 11x. And 1 plus 3 is obviously 4. It doesn't matter which method you use the one that makes sense for you. Okay, and this one we're noticing that when we look at the 7x cubed, we do have, and we don't have to bounce because there's a plus right here, so we just have to gather like terms. I have a 7x cubed, I have a negative 2x cubed. When I put that in my calculator, that gives me a 5. Of course, we can't put the x cubed in the calculator. It's just saying 7 of something, 7x cubes, minus 2, take away 2 of those x cubes, leaves you with 5x cubes. And then we notice something. We notice that there's no x squared right there. And so we'll jump to, we're already done with our 7x cubed, our negative 2x cubed, and we see this lonely x squared that's alone. We're going to put that down. We're done with that term. And then we notice we've got the negative x and a positive 9x. We put that. It's 9x minus an x. That leaves us with 8 x's. We're done with those two terms. And of course, we've got the 5 plus the 4, which is the 9. And we look for that answer. And let's see, which one is it? It is B. The next one, I see that I've got a minus sign here. So I'm going to go ahead and clean that up. I'm going to change it to a plus sign and change the signs of everything that comes after it. All right, that's the biggest minus sign ever. That's a minus sign. All right, so here we go. Let's start gathering like terms. I can do it just the way I come across it, and then we'll get in order after that. So let's see, I have an x here. There's no x in this next parenthesis, but there's a minus x here. So x minus x, gone. A cookie minus a cookie, gone. There's no more x there. So then I'm going to look at the next thing that comes my way, and that's a minus 8. Negative 8 plus a negative 3, that is negative 11. So I'm done with those. And then after that, I've got a 2x squared minus a 2x squared, gone. So I'm just left with a negative 11. I don't have to get that in order, do I? It's only one term. That was kind of fun. And then number 4, I'm going to do the same thing. I notice that over here, I've got a minus sign that comes in front of a parenthesis. I could bounce off of it, or I could just change it to a plus sign and change the signs that come after it. Only in that parenthesis, though, not in anything that comes after that parenthesis, which in this case, there's nothing. All right, let's gather some like terms, and then we'll get them in order later. Let's see, we've got the 4x squared minus 2x squared. Well, if you take 2x squareds away from 4x squared, you got 2x squareds left. So we're done with those two terms. Then we've got negative 6x plus another negative 4x. That gives us a negative 10x. We're done with those two. And then we're left with a negative 6 plus a 1, which gives us a negative 5. And we're done with the first section of this test. The next section is multiplying expressions. We've got a straight up distribution problem. So negative 4x squared times 10x squared. Negative 4 times 10 is negative 40. X squared times x cubed. We're going to add the exponent, so it's x to the 5th. Negative 4 times negative 13. I know it's positive. 4 times 3 is 2. Is it 52? That sounds good. And then x squared comes along for the ride. Sometimes people forget to write that x squared. Don't let that be you. And then we're done. There's nothing else we can do. Let's look at number 6. Once again, we're going to distribute. 8 times negative 2 is negative 16. X cubed times x to the 4th is x to the 7th, because when the bases are the same and we're multiplying, that means we add the exponents. 8x cubed times x cubed. Well, there's an imaginary, not an imaginary one, but there's a 1 there that's not written. And 8 times that 1 is 8. X cubed times x cubed is x to the 6th. And then finally, 8x cubed times 8, that's 64. And the x cubed is also included. I know that you guys did so many of these problems in the packet. I'm excited to see how well you guys do on this test coming up. So let's distribute again. We've got negative 3 times 2 is negative 6. Please remember, when it's just a t or just an x, and there's no exponent, the exponent really is a 1. And some people like to put that 1 there, so it reminds them to add the exponents. T times t squared is t to the 3rd power, because 1 plus 2 is 3. Same thing here. See that t, there's not an exponent? That means its exponent is 1. So negative 3 times 4 is negative 12. T times t is t squared, because 1 plus 1 is 2. And then finally, we've got negative 3t times negative 7, which will give us a positive 21t. And number 8, what we have here is we've got a distributive property problem here, and one here as well. And so I'm going to do the first one, the one in blue, and then we'll see what happens. 4x times 3x squared gives us 12x cubed. 4x times 5x gives us 20x squared. And I'm going to switch colors. Negative 2x squared times 8 is negative 16x squared. Negative 2x squared times negative 6 gives us a positive 12x cubed. Are we done? No, we have got to combine like terms. So I see that I've got 12x cubes here, and I've got another 12x cubes here. So altogether I have 24 of those x cubes. And then I've got a 20x squared here, and I'm going to take away 16 of those x squareds, so that leaves me with 4x squared. And we've got the same type of problem again, where it's really 2 problems in one, and when we're done with the distributing, we can go ahead and combine the like terms. So here we're going to go ahead and distribute the 3x. 3x times 5x squared is 15x cubed. 3x times x is 3x squared. Negative 4x squared times 6 is negative 24x squared. Negative 4x squared times negative 2x is positive 8x cubed. Am I done? No, because I have terms that are alike that I can combine. I have 15x cubes here. I have another 8x cubes here. So together I have 23 of those x cubes. And then I've got 3x squareds. I'm going to take away 24x squared. So I've got a negative amount of x squared, negative 21x squared. All right, that's our final answer. All right, this one is interesting because I'm going to go ahead right now and ignore that there's a 7 there. I'm going to go ahead and distribute. I'm going to say 3x times x, that's 3x squared. 3x times 5, that gives me a 15x. Then I'm going to go ahead, I almost distributed the 3x again. No, I'm done with that 3x. Negative 4 is right now, negative 4 times x is negative 4x, and negative 4 times 5 is negative 20. Okay, so now what I'm going to do is combine my like terms. My like terms are right in the middle. So I'm going to rewrite it. I'm going to bring down my 3x squared and then 15x, take away 4x's. That leaves us with 9x's. No, it leaves us with 11x's. Sometimes 11 and 9s can get switched up. And then minus 20. And we would think we're done, right? But it's like, oh, no, no. We really are not done. There's that 7. So now that we know that this is the same thing as all of this, then we know we need to bring down that 7 and multiply everything by it. So here we go. 7 times 3x squared is 21x squared. 7 times 11x is 77x. And 7 times negative 20 is negative 140. Now we're done. Okay, I know that you could also get the same answer if you chose to do this problem differently. If you chose to distribute the 7 first to the first binomial, you'd have a 21x minus 28, and then you could continue the problem, and you would get the same answer. So that's another way, and we would still get the same answer. I love math, how there's usually more than one way to do a problem. Gives us some options. All right, just like x squared needs x times x, when we see 6x minus 5 squared, that means take 6x minus 5 and multiply it by itself. So when we do this, we're going to go ahead, and I want to stop here and notice, you know, we don't do power to power because there's a minus sign here. If there's a minus sign or plus sign, if you've got a binomial or a trinomial raised to a power, then you've got to write it twice or 3 times. Well, we're not going to do to the 3rd power. We'll do that in Algebra 2 trade. All right, so I'm going to write it twice, and then it's an old problem, right? So 6x times 6x is 36x squared, and 6x times negative 5 is negative 30x, and negative 5 times 6x is also negative 30x, and negative 5 times negative 5 is positive 25. Now be very, very careful. Sometimes people see these 30x's and they think they're gone, they cancel out. No, because they're both negative. So we're going to bring down the 36x squared. There's nothing to combine with it, but we see a negative 30x minus 30x. If you put negative 30x minus 30, well, if you put negative 30 minus 30 in your calculator, you're going to get negative 60. So it's a negative 60x plus 25. Are there any other like terms that we can combine? No. All right, another one. Let's go ahead and start distributing like crazy. 4x times 6x, 24x squared. 4x times 7, 28x. Negative 5 times 6x is negative 30x. And negative 5 times 7 is negative 35. We do have some like terms to combine, our middle terms. So we bring down the 24x squared. We say 28x minus 30x. We put 28 minus 30 in our calculator. We end up with negative 2x. And because there are no more like terms to combine, that is our final answer. Okay, another one, and this time we've got a binomial times a trinomial. So we're just going to keep on distributing. First, we're going to distribute that x. So that's a 2x cubed, and that's a minus x squared, and that's a minus 5x. And then we're going to keep going, and we're going to distribute the 4. 4 times 2x squared is 8x squared, and we'll have a minus 4x, and we'll have a minus 5. Oops, no. 4 times negative 5 is not negative 5. 4 times negative 5 is negative 20. And now we're going to go ahead and gather like terms. The 2x cubed stands alone. There's no other term that's like it to combine, so we're done with that. We see that we have a negative x squared plus an 8x squared. That's going to leave us with a 7x squared. Then we see that we've got a minus 5x minus a 4x. That's a minus 9x. And then we've got, so we're done with those. And then we've got a minus 20 just hanging out here on its own. Because there are no more like terms, that is our answer. Which brings us to application. So here we go. When they ask us to find the perimeter, that reminds us that perimeter is just adding all the sides up. So we could write this the long way. I'll tell you what, I want to make this video a little shorter than I'm making it because I know you guys did that long packet and you're good to go, ready for the test. So let's just get straight to the answer. Here we go. Let's add up all the like terms. 4x plus 2x is 6x, plus another x is 7x, plus 7x is 14x, plus 3x is 17x. Then we're going to do the same thing and say minus 3 plus 5, that's a 2, plus 6, that's an 8, plus 3, that's an 11, minus 2, that's a 9, and this, my dear ones, is our final answer. Write an expression to model the area. Now, area is length times width when we're dealing with a rectangle. So here's our length and width. We're going to multiply them, 7x plus 2 times 8x minus 3. And we know what to do, right? We are pros at distributing and getting a binomial times a binomial. And then, that's 16x. And that's a minus 6. We're going to combine our two middle terms. So we'll have 56x squared, and we'll have, what, a minus 5x. And we are done. There are no more like terms to combine. Okay, so we talked about in class here where to find the area of the shaded region, well, we didn't. We talked about it in the tutorial. We're going to take the area of the big triangle, which is 14 times 3, which is what? 3 times 4 is 12. Here, the 1 is 42. Then we're going to subtract the area of the smaller rectangle. Did I say triangle? I'm hoping I really said rectangle at first. You know what I meant. So we're going to subtract the area of the smaller rectangle. And the smaller rectangle, I'll do that real quickly. The area of the smaller rectangle is 4x times x plus 2. So we're going to distribute again, and we'll get that equals what? 4x squared plus 8x. So we're going to put the area of the smaller rectangle in here. And this is actually a good way to write it because it shows us that the 42 is the area of the big rectangle, and we are subtracting from that the area of the small rectangle. We could distribute that minus sign and combine like term. Well, there's no like terms to combine. That's a perfect way to write that answer. Okay, and after that, I am seeing that we do not have the rest of the practice test. So let me pause this and get the, nope, that's not it. Let's see. We will pause and we're back. All right, properties of exponents was missing, so I had to go quickly find it. And here we go. Once again, if these using the properties of exponents are difficult for you, please go back and review the Poly Packet tutorial number 5 because we go over the properties of exponents. And yes, you have to memorize them because you have to use them. So here we've got this 2 right here goes to everything, the 5, the x squared, and the y to the 5th. So we'll have 5 squared. We'll have x squared to the square. When we do that, we have 2 to the 2 is power to power. We multiply. And then y to the 5th, also squared. Power to power, we multiply the 2 powers. We're almost done. 5 squared is 25. And we are done. That made sense to you and it matches your answer. Good for you. If not, go back. Do more stuff in the packet. All right, here we go. We're going to be multiplying. First of all, an 8 times 4 is always going to be 32. There's no new rules for multiplying numbers. But there are the new rules for when we have an x to the 5th times x to the 1st power. Same base, we're going to add the exponents. 5 plus 1 is 6. And when we look here, we've got y to the negative 3 times y squared. Same base, we're going to add negative 3 plus 2 is negative 1. Can we leave our answer with a negative exponent? No, it says without leaving any negative exponents. So just as we learned in the video, everything gets to stay on the top, the 32 and the x to the 6 do. Y to the negative 1 actually has to go to the bottom. To the denominator, and when it does, we could write it as y to the 1, but we know we don't really need that 1. We're just going to write it this way. Once again, if you miss any of these, please ask me for, come to lab and ask me for how to do these. So here we go. We've got division. If we're just looking at the 12 divided by 6, we know 12 divided by 6 is 2. That rule has not changed. But now as we look at the x's, we have x to the negative 4 over x to the third. And we know that over, that fraction line really means division. So when we have the same base, when we're dividing, we're going to subtract the power. So we have negative 4 minus 3, which is a negative 7. Then we're going to look at the y's. We have y to the first power over, or divided, by y to the third. Same base, we rewrite the base. 1 minus 3 is negative 2. And then we see the 0 to the 0 power. Anything except for 0 to the 0 power is equal to 1. We are done with that. We don't need to do anything with it except for realize that it's 1. Can we leave our answer in this form? No. The 2 is fine. The 2 is going to stay up here. If we put the 2 in the denominator, we would change its value to be a 1/2. So we're only moving our variables that are raised to an exponent. X to the negative 7, we cannot leave it that way. It goes to the denominator. Y to the negative 2 goes to the denominator. When you have them go to the denominator, they lose their negative sign. And if you want to know why, watch that tutorial again. All right, I'm going to put the key myself. Let's just keep going. With this problem, what I would do is simplify your parentheses first, then raise it to the power of negative 3. So what would it look like to simplify this? Well, I have x to the 5th over x to the first power. I know same base, we're going to subtract. 5 minus 1 is 4. And then I have y to the 7th over y to the 8th. Same base, we're going to subtract. 7 minus 8 is negative 1. So doesn't that look better than the big mess at first? So I've rewritten what was in the parentheses, and now I can remind myself, oh yeah, what's in the parentheses is being raised to the negative 3rd power. Now I've got the power to power rule, and so I see that I've got x to the 4th raised to the negative 3. Power to power means to multiply. 4 times negative 3 is negative 12. I've got y to the negative 1 raised to the negative 3. Power to power means multiply. Negative 1 times negative 3 is 3. Can I leave my answer this way? Not quite. I'm looking for negative exponents, and if I have one, I've got to draw my fraction line. Anything with a positive exponent gets to stay on top. Anything with a negative exponent gets to move to the bottom. That is your answer in its final form. I think we just have 2 more. Yep, these last 2, I'm going to focus on one fraction at a time. So I'm going to simplify this fraction, and then I'll come back and simplify the other one. So here I've got x to the negative 3 divided by x to the 3rd. I know that same base. We're going to subtract the powers. Negative 3 minus 3 is negative 6. Then I've got y to the first power over y to the 13th. Same base. 1 minus 13 is negative 12. So then, I'll put my little multiplication dot. I'm going to work on the second fraction. I don't have an x up here. So that's going to be something interesting. I'm going to go ahead and there's a couple different ways I can do this. Why don't we do this? Why don't we leave it here for a second? We'll leave it down here, and we'll figure it out. Here I've got my y's. I've got y to the 8, and over y to the negative 5. 8 minus a negative 5 is y to the 12th. Yes? 13th? Yes? Okay, so I know that looks funny. I really struggled with what the best way was to teach this, but then I remembered, you know what, I taught this in the tutorial. So here we go. Let's look at the x's. I've got, when we bring this whole thing together, we've got x to the negative 6, y to the negative 12, times y to the 13, and that fraction bar goes like that. So we've just got the y's and the x's to clean up. I'm looking at the x's first. X to the negative 6 over x to the 1. Negative 6 minus 1 is going to be x to the negative 7. And then I look at my y's, I've got y to the negative 12 times y to the 13, same base. I'm going to add this exponent, and I'll just get y. I'm almost done. I can rewrite that, keep the y out in the numerator, and kick the x out into the denominator. And that was one way to do it. When I paused, the place where I paused, I want to show you there's another way we could have written this. Instead of y to the 13 with the x there, we could have said, you know what, that x in the denominator, that same x can be written as x to the negative 1. That way, everything's in the numerator, and then it's just all about adding. So then I'd have x to the negative 6 times x to the negative 1, which would give me x to the negative 7. And then y to the negative 12 times y to the 13th, that still would have given me just plain old y. But it would have given me the same answer. It might have been an easier way to get either method you would use. Just get the correct answer. All right. And our last one seems easy in comparison, doesn't it? Let's go ahead. We've got this 2 on the outside. We know what to do. This 2 goes to everybody. The 9, so that's 9 squared. If you want to do that in your calculator, it gives you 81. That's x squared, which is x squared. And then we've got y to the 8 to the second power. Power to power means to multiply. 8 times 2 is 16. Then we've got to multiply. Here it's like, that's not all. Then we have to multiply with this next 2x y to the 7th. I was going to say the next term, but it's really all one big term, isn't it? So here we go. 81 times 2. I don't have a calculator in front of me, but that looks good, right? And then x squared times x. That's the same thing as saying x cubed. And we have y to the 16th times y to the 7th. Same base, so I'm going to add 16 and 7, and hopefully we can get 23. And we are done. Thank you for joining me. Look over your practice test, look over your packet, and then call it a day and test.